Alright, with Unit 1, I'm mostly going to be focusing on the complex numbers and our powers of I. We have a lot of videos already up on factoring. I will do one, but remember, I'm going to show you guys you can check your solutions for factoring on your calculator. Plus, you can always use the quadratic formula. But starting out, I'm going to start in Unit 1 with number 1 and 2 with your powers of I. So you've got to remember, I to the 1, I to the 2, I to the 3, I to the 4. Remember, these powers repeat. And I like to think of my lottery. I won with your negatives. And this repeats every 4, so you can always check which power of I it is. If you're given I to the 50th, you can divide it by 4 and see which decimal you get to go back with one of these powers of I. You will always simplify these powers, okay? So, by what I mean in number 1, starting out with this one, we're going to multiply across. So I'm going to take -2, -7, and then in front of that I to the third is technically a 1. So that's going to give me 14. I'm just multiplying across. Now, with all these exponents, I'm going to have a base of I, but anything with the same base, you're going to add exponents. So I'm really going to take 5 plus 10 plus 3, giving me I to the 18th power. Now, that's not simplified. You can tell that's not even one of your answers, so we've got to take 18, divide it by 4, and see what you get, because that's going to tell me which power of I, if I keep repeating this pattern, what it all will get back to. 18 divided by 4 is 4.5, so I really only care about this 0.5 part right here, because that matches up with I squared, which the value of I squared is -1. So I to the 18th, when this cycle repeats back through, will go back to -1. 14 times -1 would give you -14, which is D. Now, with simplifying, if you're adding, all you have to do worry about is combining like terms. But with subtracting, and when you have these negatives, you've got to make sure you distribute the negative values. So the first one, or the first set of parentheses, I'm pretty much multiplying everything by -1, which all that's going to do is change the sign, giving me 3 minus I. The second one, I'm going to multiply by -5, giving me -10, because -5 times 2 is -10. -5 times -8 is a positive 40I. Now that I've distributed, got rid of the subtraction part, all I'm going to do now is combine like terms. So we know our I's will go together and our constants. And standard form always tells me the I's go last, because that's imaginary, and my rational numbers go first. So 3 minus 10 is -7, and -I plus 40I is a positive 39I. So the answer choice for this one would be A. Alright, moving on. Sorry, I gotta go back through the stuff from my table. Division is very similar to multiplication, or thinking back to multiplying by x's. But to divide, you've got to multiply by the conjugate, which is just taking the denominator and changing the sign in between. You do that to the numerator and you do that to the denominator. Now, division, or multiplying by the conjugate, is just doing multiplication twice. So you're going to do 2 boxes or 2 area models, because that's going to be multiplying. So I'm going to do one for the numerator. So I've got to do 2 plus 3I times 5I, and I've got to do the denominator, which is 5 and minus I times 5. Oops, running out of room, let me go back up. 5 plus I. So I'm going to multiply on the inside, and then this is my numerator, this is my denominator. Multiplying by the conjugate. 2 times 5 is going to give me 10. 3I times 5 is 15I. 2 times I, which is 2I. 3I times I would be 3I squared. And be careful, This I squared is one of your powers of I that simplifies to be negative 1. So really this is saying 3 times negative 1, which would give me negative 3. 5 times 5 is 25. 5i minus 5i, which is what we want, and then negative I squared. Again, we have an I squared, which is negative 1. So saying that I have a negative 1 lets me have a positive 1. So you've multiplied inside your boxes. Now you just got to combine your like terms. So the constants are good with the constants, and the i's are going to go with the i's. So 10 minus 3 for the numerator is going to give me 7, and 2i plus 15i is 17i. Now this is really nice over here because these are going to cancel out. Negative 5i plus 5i is 0 i's. And then you just got the 25 plus 1, which will be 26. So I'm going to set my numerator over my denominator. Split it up in case I need to simplify. So this would have to give me a. Now, the last one, number 4, that I'm going to do, actually I'll do 4, 5, and 6 because I'm feeling generous. And then you guys got some extra practice in Unit 1 you can do. So this goes back to my factoring. Number 4, before I can factor, especially choosing the best method, we always want to check factoring first. So this guy, x squared minus 6x plus 9, I moved the 9 over because to factor, we've got to make sure it's set equal to 0. So I'm going to see if I can even factor. So I'm going to do my a times c over b. A times c is 1 times 9, which is 9. And my b is going to be negative 6. So I got to see what multiplies to give me 9 and adds to give me negative 6. The only two numbers that's going to be is negative 3 and negative 3. Since there is a is 1, I don't actually have to put it in the box. I can take a shortcut. I know that the factors are going to be x minus 3 times x minus 3 equals to 0. And to solve, you take both factors, set them equal to 0. So I would add 3 over. So both of them are going to be the same, so x is going to equal 3, which is a. Now I'm going to show you really quick because you can check that on your calculator. So I would go to my y equals. Let me go ahead and clear this out from last time. So hit my y equals. I want to put in the function now that I've set it equal to 0. So I'm going to put x squared minus 6x plus 9. Your solutions are going to be the same thing as your x-intercepts, anything like that. And you notice it hits or touches the x-axis and goes back through it at x equals 3, which is what we said was the solution. So if you graph any quadratic and you see that it goes through something like, this is just another example, we got here, the two solutions for this parabola or quadratic would be negative 3 and negative 7. That's another way to check yourself. Since this is multiple choice, I'm not grading on whether or not you can factor or not. I just want the right and correct answer. It'd be nice for you to practice it because next semester we are going to go over it. Alright, solving by taking the square root. I can't factor number 5 or do the box or anything because it's got parentheses in it. So I'm going to add a piece of paper and rewrite this one to give me some room. So when you're solving by taking the square root, you want to get everything away from the parentheses so you can take a square root. So treat it like solving. I want to move this 6 first. Have would give me 6. Divide both sides by -2. So now I'm only left with the parentheses squared, which I can undo by taking the square root of both sides. When I do that, these cancel out because a square root undoes a square, leaving me with x plus 5. Oops, I've got a negative under my radical, so it's going to be plus or minus I root 3. I can't break 3 down because it is prime. And almost there, I'm solving for x, so I'm going to subtract 5. It'll be -5 plus or minus I root 3. That would be my final answer, which, if we go back, -5 plus or minus I root 3 would again be A. We got a lot of A's going on here. I guess that's not bad. So, my suggestion for this one on number 6, remember this is doing b squared minus 4ac. You've got to set it equals 0, put it in order, so if I move 16 over and add it, you can now plug this in to find your answer. Your A would be 1, your B would be 16, your C would be 88, which is very much like the quadratic formula. So if you did 16 squared minus 4 times 1 times 88, you should get, hold on, -96. So this is less than 1. It's a negative number that would be under the radical, which means, oops, at the end of A, you've got an imaginary solutions. If your discriminant is equal to 0, you have 1 real solution. And if your discriminant is positive, you have 2 real solutions. So that's pretty much all you have. I did want to add another one just because I think it would be a good one for you guys to see. Just something like this. It's not on the review, but it will be on here. So make sure you multiply both on the outsides. This will give you I squared will be your -1, which will be -2. The root 20 we've got to break down, which is 4 times 5. That becomes 2 times 2. There's your perfect pair. So that with that -2 on the outside, I'm going to have to bring out a 2, leave a 5, -4 root 5 would be the answer of that one. So go ahead, try that one yourself. There are some review for that one in your packet also.